All right, let's talk about a breakthrough that could seriously change the entire game for AI. I mean, what if you could get genius-level AI performance, but without that genius-level price tag? Well, a new model from a company called DeepSeek says it can do just that, and trust me, this could change everything. Let's dive in.
Just to put this all into perspective, think about this for a second. What if an AI could read and analyze an entire novel for what it used to cost to analyze a single paragraph? I know, it sounds like something straight out of sci-fi, but that's the scale of the leap we're talking about. This isn't some small, incremental improvement. It's a total shift in how we think about AI efficiency.
So how on earth did they pull this off? Well, it all starts with a huge kind of hidden problem that's been lurking in the background of modern AI. Let's call it the long context problem.
And here's the crazy catch-22. On one hand, these massive AI models can process just insane amounts of information. We're talking entire books, huge code bases, you name it. But here's the thing. Asking them to do that is kind of like using a rocket ship to go to the corner store. The power is there, sure, but the computational cost is so enormous, it's just not practical for most people. The real root of this problem has a name. And if this were a movie, it would be the main villain. It's called the attention bottleneck. You see, deep down inside every large language model, there's this core process called attention. It's basically how the model figures out which words and ideas in a huge chunk of text are the most important for getting you the right answer. It's how it focuses. But the way it's usually done has a massive critical flaw. And here it is. It's a nerdy math term, but it's super important: quadratic complexity. In plain English, it means that if you double the amount of text you give an AI, the work it has to do to pay attention doesn't just double, it quadruples. Double the text again, and the cost goes up by 16 times. You can see how this spirals out of control, right? This is the bottleneck that makes long-form AI so ridiculously expensive. Here's a great way to think about it. Standard attention, that's like you're standing in a massive, noisy party. And to understand one conversation, you're trying to listen to every single person in the room at the exact same time. It's just insane. Totally wasteful. The new, smart approach is like having an assistant who taps you on the shoulder and says, hey, forget everyone else, just listen to those 3 people over there. The difference in efficiency is just night and day. So, how do you fix a problem that's baked into the very heart of these models? Well, this brings us to the hero of our story, this brilliant, clever shortcut from the DeepSeek AI team. They came up with something new called DeepSeek Sparse Attention, or DSA for short. And the key insight here is that it's not about making the AI work harder, it's about making it work smarter. DSA is basically this super intelligent filter that lets the AI skip all the junk and focus its incredible brain power only on the bits of information that actually matter. And the way it works is actually pretty elegant. It's a 2-step process. First, you have this component they call the lightning indexer. It zips through all the text and gives every little piece an importance score. Then, step 2 is the top case selector, which acts like a bouncer at a super exclusive club. It looks at all the scores and only lets the absolute VIPs, the top 2,048 most important tokens, get through to the main AI model. It's like finding the needle in the haystack before you even start searching. Okay, this all sounds amazing, right? A faster, more efficient AI? What's not to love? But here's the million-dollar question. Did this shortcut make the AI, dumber? Did they have to trade quality for speed? Well, the answer, straight from the researchers themselves, is a big, fat no. In their paper, they state very clearly that they saw no substantial performance degradation. That's a huge deal. They're basically saying they found a way to get all the speed and efficiency without losing any of the smarts. And the numbers, well, the numbers really tell the story here. Just look, when it comes to general reasoning, it's a dead tie. For complex coding tasks, the difference is so small it's basically a rounding error. And get this, in advanced math, the new, more efficient model actually scored a little bit higher. The takeaway here is crystal clear. They didn't have to sacrifice any of the genius to get this new efficiency. So, we've established that performance-wise, it's a wash. The new model is just as smart. But the cost. Oh, the cost. This is where a little tweak in the architecture leads to an absolutely massive earthquake for the entire industry. Okay, first, let's look at the old way. See this big, tall bar?
That's the cost to process a really long document with the previous model. It comes out to about 70 cents for every million tokens. That right there is our expensive attention bottleneck in action.
And now, brace yourself. For the exact same job, this is the cost of the new model. That bar doesn't just shrink, it completely collapses. From 70 cents all the way down to 10. That's it. That is the jaw-dropping power of this innovation all in one simple chart. So what on earth does this mean for the real world? This isn't just some cool tech demo. This signals the beginning of a totally new era. We are talking about the new economics of AI. Let's just put one big number on it. This new method eliminates about 85% of the cost for these huge, complex AI tasks. And when you slash the cost of a technology this fundamental by that much, you don't just make it cheaper. You totally change what's even possible. So what does this unlock, really? Well, all of a sudden, having an AI analyze a company's entire financial history or sift through thousands of legal documents, that's not just possible, it's actually affordable. It puts the best AI tools into the hands of startups and individual developers who were completely priced out before. And maybe most importantly, it gives us a blueprint for how to build the next generation of AI to be even more powerful and way more efficient. And that leaves us with one last massive thought to chew on. This breakthrough is a giant leap towards making complex AI thinking radically cheaper. So as the cost of having an AI think gets closer and closer to zero, what are the really big, world-changing problems we're finally going to ask it to solve?